All right, we're back, and in this segment, we're going to talk about why correlation does not establish causation. And I've had, a lot of students over the years who already know this. I had one student who came to class wearing a t-shirt that said correlation does not establish causation. I thought that was pretty clever because who has a t-shirt that says that? I've seen it on coffee cups and stuff. So you may have heard this, you may vaguely know that this is true, but you might not be exactly sure why. So hopefully I'll give you some really concrete examples of why correlation cannot establish causation. All right. First, let me give you an example. So back in 1986, there was a survey that was conducted of 3,500 respondents. It was called the Good News Survey, and it asked questions about all sorts of lifestyle factors like, what you had eaten for breakfast as a child, whether you ever took vitamin pills, how much TV you watch, have you ever had cancer? It's all sorts of things that didn't necessarily look independently like they were related. And then the researchers did something that we try not to do in psychology, which is what we call data mining. So what they did was they took every single variable that they had assessed in this survey, and they entered it into a series of correlation analyses. And they just looked to see which ones would pop out as related. That is not how we do science, right? You want to make a hypothesis ahead of time and see whether or not the data supports your prediction. So they weren't doing great science, but they provided for us something really interesting. So they found that people who reported having eaten frosted flakes as children reported lower cancer rates than people who reported eating Quaker oats for breakfast when they were children. All right, so hopefully your spidey senses are already up because you already know that Quaker oats not only helps you lower cholesterol, it's been associated with reduced rates of colorectal cancer in particular. So you hopefully are thinking to yourself, something's off. But maybe you're having trouble figuring out what could be off. Now, I've introduced this Good News Survey to my online introductory psychology students in the past and asked them to discuss what could possibly be going on with this correlation. And I've had students say things like, well, maybe the preservatives in the frosted flakes are actually somehow protective and preventing cancer. Or I've had students say, well, a lot of people make Quaker oats with water and maybe their water is tainted. Or maybe the fact that you eat frosted flakes with milk more often means that you're getting some kind of dietary benefit from the milk. And that's really the factor that's important. I think those are pretty creative explanations, but I'm going to come up with a simpler explanation, right? We always want to go with the simplest explanation possible, right? So the Good News Survey was conducted in 1986. Frosted Flakes were invented in 1952. So in 1986, people who ate Frosted Flakes as children were probably no more than like 45 at the time of the Good News Survey, maybe 50. Whereas people who ate Quaker oats for breakfast could be any age and probably tilted a little bit older, right? So what do you guys know about cancer rates and age? Right? They tend to be associated with each other. We become more vulnerable to cancer as we age. So it's possible, indeed I might argue probable, that there is no real relationship between Frosted Flakes and cancer rates. No real, maybe except for with the protective value of Quaker oats and colorectal cancer, I'd say there's really probably no association between what the person ate for breakfast as a child and then their likelihood of developing cancer. Probably this association is emerging because of this third variable called age. So, okay, I will come back to that in a little bit. Let me give you one more example. Still focusing on the Good News Survey. They found that people who reported having taken vitamin pills as children were more likely to report having used illicit drugs as adults. And remember, in 1986, everything that you're seeing in that picture was an illicit drug. So again, we have to start wondering, why would these two things go together? And my intro students have said things like, well, maybe if you take pills when you're a kid, you start to think that taking pills or other substances is actually good for you. And so you generalize that to illicit drugs. And I'm like, that's creative. That is a stretch, but that's creative. Okay, probably that's not it. I don't mean to sound like a broken record or anything, but vitamin pills were introduced in the 1940s. So again, you're looking at people who, when they took the Good News Survey in 1986, were in their 40s, maybe early 50s. And in 1986, a person who was 40 was like 20 in 1966, when people were tuning in and dropping out and doing, a lot of experimental drug use up through the 70s, right? Whereas people who were older than that probably didn't do those things. So probably, again, it's just this spurious relationship between taking vitamin pills when you're little and then using illicit drugs when you're older. And it probably is all just a function of age. So let's quantify what I've been talking about. First off, there's the directionality problem. In psychology, we've known for a really long time that there's a correlation between self-esteem and achievement. But what we can't seem to figure out is whether high self-esteem leads to greater achievement or greater achievement leads to higher self-esteem. The fact that that arrow is double-headed is the directionality problem. Does self-esteem cause achievement, or does achievement cause self-esteem? With correlations, we can never figure it out. There's no way to figure it out. There's nothing you can do using correlational research that would ever answer that question, because we don't have control over the variables. All we do is measure the two variables, right? So we measure a person's self-esteem with some kind of self-esteem scale. We measure their achievement however we want to define it. It could be income, it could be GPA, it could be winning a race. It could be whatever we want to use as our measure of achievement. However we want to operationally define these variables. And then all we can do is perform a correlation on these two variables and see if they go together. We cannot say one predicts the other. We cannot say that one causes the other. We just can't. It's a limitation. And so when we look at a correlation, we always have to think to ourselves, if there is a cause between these two things, which way would it flow? And we've seen psychologists arguing this one out for a really long time. Some argue that boosting a person's self-esteem will motivate them towards greater achievement. Others suggest that experiencing success, achieving things, will boost a person's self-esteem. So we have different camps, and we can't really answer the question using correlational research. They've done, by the way, other attempts to test this that would be potentially getting at causation. They control the person's level of self-esteem by doing a temporary threat to their self-esteem or something, and then see if that has an impact on their achievement towards finishing a puzzle or something like that. And that research has been kind of mixed based on how they've threatened the self-esteem and what they've used as measures of achievement. So we still don't have a solid answer to the question, but it's an interesting question and one that can't be answered through correlation coefficients. Now, the two examples I gave previously, I kept relying on the third variable problem as the explanation for the relationship between what you ate as a child and cancer, or whether you had taken vitamins and then subsequently used illicit drugs, because it's really hard to make a directionality argument, isn't it? I don't think there's any way that we could say cancer causes you to have eaten this as a child. Like, that doesn't work. So we're going to have to rely on third variable explanations for some correlations. Like, you just have to. In this case of this correlation between self-esteem and achievement, the spurious correlation might be that there's a third variable present that we're not measuring. Maybe parental support determines your level of self-esteem and determines your achievement orientation. Or maybe certain personality characteristics that you have determines your level of self-esteem and your pursuit of achievement. We don't know if we haven't measured that. And so the idea that there might be some third variable that would be a better explanation for this relationship needs to always be considered. it's possible that something else is causing these two things to be related to each other. So let's give you another example. And I want you to keep in your mind explanations that could be based on directionality or on third variable. Okay, so a study from 1985 revealed, they were looking at television sets. There have been updates to this study, by the way. In 2017, an update came out, and they just looked at screen time. So it's not just TV. But what they've found is that for kids who exceed 1 hour per day of screen time, who are between the ages of 12 and 17 years old, there is a 2% increase in their BMI. So it's not a perfect one correlation. So it's the case that some kids watch more TV and have a lower BMI, and some watch less TV and have a higher BMI. And so there's some variability. But the general trend is that on average, kids who spend more time in front of screens tend to have higher BMIs as measured by, that period between 12 and 17 years of age. So we could think about a directionality problem explanation. Like, why would there be this association between screen time and obesity or BMI? What directionality explanation could we look at? Well, it's possible that screen time leads to BMI, right? But it's also possible that people who have higher BMIs are maybe not attracted to the other kinds of activities that maybe don't involve screens. And so they find themselves watching more TV or YouTube or whatever they do. So because of their BMI, they're spending more time in front of the screens rather than the screens driving the BMI. It could be that BMI is driving the screens. So the direction could flow either way. And we don't know whether it's actually even one causing the other. We just need to be really, really careful when we hear. See, I picked this one on purpose because a lot of times our logic goes, well, of course, if you watch a lot of TV, you're going to gain weight. Like, it just seems so logical. But you still, even if it sounds logical or fits your narrative, you still have to think about alternative explanations when you see a correlation. So it could be directionality that would make us say, maybe it isn't the case that just pure screen time increases weight. Maybe weight increases screen time. The other interpretation is the third variable interpretation. And in this interpretation, we're going to look at other factors outside of just the screen time and just obesity. And we're going to look at what might be driving both of those things. So, for example, in my classes, oftentimes my students will offer that if you have a child whose parent is working full time and isn't going to get home till 5:30 or 6 o'clock at night, and the child has gotten home from school at 3:30 or 4, they may have some unsupervised time where they get to watch more TV and maybe consume things that mom and dad might not have approved of. Or maybe mom and dad don't know that that the child has been consuming snacks and then feeds the child dinner too. And so they're getting more calories than they need because of that. I've had students also point out that when you're watching a lot of screen time, that you might be influenced by the advertisements for different kinds of foods and things. And so you might be attracted to, sugary snacks or high fat snacks because you've been shown those on TV. And so it could be the content of what's on the screen that might help to drive the association between screen time and obesity. So we have to think about, whenever we see a correlation coefficient, we have to think of alternative explanations that will help us to understand that this correlation does not establish causation and that there are probably legitimately other factors that might contribute to this correlation. So keeping that in mind, here we have a correlation between, in the blue line, ice cream sold, and in the red line, number of murders. So we could go with the simplest explanation, which must be true, and that would be that after a murder, one wants to consume some ice cream. That's possibly it. Or possibly eating ice cream gives you brain freeze and it makes you really, really angry, and so you commit a murder. Or it's possible, so those are my directionality interpretations, or it's possible that there's a third variable in play called what month is it? And as the months get hotter, more ice cream is sold, and also people get more murderous. And so a third variable called temperature might be driving ice cream sales and murder rates. So it's really super important. I'm giving you some kind of simple examples. I'm giving you ones that maybe your knee jerk wants to go, well, of course that makes sense. And then you have to really stop and think about it and say to yourself, why would these two variables be going together? Is one causing the other? Do I really believe that? If I believe that one's causing the other, do I feel confident that I know which way that direction flows? Is there evidence to support my belief, or am I just sort of knee-jerk agreeing with something? Or is it possible that there's something outside of this study that isn't being factored into this correlation that might better explain why these two things are going together? So always remember the third variable and the directionality problems. So, in conclusion, correlations really are the bread and butter of psychological research. I mean, if you randomly selected, 3 studies from the field of psychology, probably 2 of them have a correlation reported within them. They are the bread and butter. We do them all the time. They allow us to study things that we probably couldn't study otherwise. They provide us with really valuable information. Like, for example, if we see that self-esteem and achievement motivation are correlated with each other, it helps us to generate maybe a hypothesis about why we think that those two things go together. And then we might develop a study that might help us to answer our question, something beyond a correlation, something that we'll talk about in other chapters. So it helps us with hypothesis development. Because if 2 variables go together in a correlation, it's possible that one might cause the other. And so our job is to try and figure out which one do we think is the causal one? How could we set that up and manipulate it? How could we get control? So if 2 variables go together, it makes us think it might be worth it to develop a true experiment, right? If they don't go together, don't even bother making an experiment. If you don't have a correlation between these 2 variables, there's no point in trying to get control and see if now your control causes something, because the 2 things don't go together. So there's no point in going to the trouble of developing a true experiment. So it's really good for hypothesis development, because if we see these 2 things go together, it spurs us to develop ideas for how to figure out whether or which one might be causal. In psychology, this is really the only way to study some topics. There are some topics that there is no way we would ever be able to do an observation or a true experiment or something where we could have control, right? Because some topics, like for example, studies of how old a person was when their parents got divorced, and perhaps, GPA. We can never get control over either of those things, can we? We can't randomly assign some people's parents get divorced when they're 4 and some people's parents get divorced when they're 8. And you can't do it. All you can do is study what is already there. And so correlations would be the only way that we could examine that kind of question, the relationship between age at parental divorce and then GPA in 6th grade. There's no other way to study that except for correlations. So knowing the limitations of our subject matter makes us need to be really super cautious about interpreting correlations. We need to be open to using correlations in our research, but also to learn how to talk about correlations in these really careful ways. We don't want to go beyond what the correlation can really tell us, is the basic warning I want to give you. So you got to view it with caution. Don't think to yourself, well, I'll just never do them in my research, because the thing is, you probably will. I actually said I'll never do correlations, and I just did one in the last study I published. So I would recommend not saying you'll never do it, but it might just be a starting point for you, and then you want to move to something else if you're in certain areas of psychology. So you want to view it with caution. And then I really want to leave you with this last, viewing it with caution. Correlations are reported in all sorts of media all the time, whether it's, from parenting magazines or Glamour magazine or the news when they report on findings. Whether it's medical findings or psychological findings, they're usually reporting correlations. And so when you hear these things reported on the news or wherever you've read them, maybe it came across your social media feed or something, always think to yourself, whoa, these two variables were only measured and the relationship was established. These reporters seem to be taking this beyond what we could be doing with a correlation. I need to not get sucked into their incorrect impression that one thing is causing another. One that's coming to my mind is teenagers who stay up past 11 p.m. tend to have more symptoms of depression and anxiety. This was reported in a parenting magazine that I read. And the way that it was, and then their advice, because this was for parents, was to make sure your kids get to bed earlier. Well, that's great. Except for one thing, we don't know that it's the lack of sleep that's causing the depression and anxiety. Lack of sleep can be a symptom of depression and or anxiety, right? So we don't know which direction it flows. And we don't know that forcing your teenager into bed is going to cause them to fall asleep. Like it was such a crazy example, perfect, of how the media tends to report these kinds of associations. So you just have to be really cautious when you hear these kinds of results reported, and make sure that you don't leap to the causal conclusion that the writer wants you to. All right. Well, we will meet back up in the next chapter, and don't worry, we will talk about correlations again in class. So this was just a little warm up. All right. See you in the next chapter.